Hi, welcome to Cosumnes River College. My name is Rick Stewart. I'm a student here at CRC, and I'm really happy to be a student here for several reasons. First and foremost is the quality of the education I'm getting here at school. The second is the fact that our school is undergoing some construction in coordination with the light rail, but we're also doing a lot of things with some solar panel that will help in the sustainability of not only the school, but it also helps the planet. We've got a couple new buildings here on campus that we're going to show you today, and we're going to talk about them and how it's working out for us. So let's take a look at a couple of the buildings here today. Okay, we're on the top floor of the parking structure, which is one of the new buildings here on campus. And as you can see behind me, the solar array that we have here, we've got two of them. There's another one right there in front of me. But let's give you a little bit of information about what these are all about and how they work, and then how it actually benefits the school itself.
First off, I'm not an engineer or a scientist yet, so I gratefully relied on information I received from Danny McKevitt from the engineering enterprise, who was the electrical engineer for the project, as well as support from Glenn Kaneyuki, who was the project manager for the Cosumnes River College parking structure project. First off, a quick overview of what a solar panel is and does. Solar panels are a combination of multiple photocells that receive sunlight onto a silicon wafer type component that is able to convert the solar radiation energy into direct current electrical energy. Depending on how many of these photocells are combined in each panel, will tell how much potential solar energy you might be able to produce. In this view, you get a glimpse of the structure and the overall length of a group of the panels. There are 1,056 panels on the roof of the structure, and each of these panels are 3 feet by 6 feet. When multiple panels are grouped together, it is called a solar array. At CRC, each panel is rated at 275 watts, and the combined parking structure array is rated at 290.4 kilowatts of DC, which we as consumers can't use for our computers, but I'll show you how we change that in a moment. All of the panels on the roof are connected together into what are called combiner boxes, which simplify getting the power from the panels to the system's inverter. Just imagine the mess of having all these smaller wires together. The combiner boxes take many panels and connect all of these smaller wires and make a lot less bigger wires to feed into rooftop DC disconnects, which then feed into the system's power inverter. The panels here at CRC are made by a company called SunTech and carry a 10-year warranty. As the photovoltaic or PV technology is advancing, these panels are conservatively rated and are expected to retain up to 80% of their power-making ability even after 25 years. Okay, so we have power, and it travels through a maze of ductwork to get to the electrical room where it enters into the power inverter. This inverter is where the panel's DC current is converted into alternating current, or AC power. AC is what we need to power everything we plug into the wall at home, business, or school. The type of power created by the system and converted here is much more powerful than anything you would ever need or be able to have at home, but for CRC, it's necessary. The inverter's life cycle is approximately 10 to 15 years. Once the DC has been converted to usable AC power, it is connected to the main switchboard, which is the same place in the electrical room where we would be receiving power from SMUD if we needed it, or perhaps at night when we receive no solar input. The power moves through a 400 amp breaker, which has a meter that tells SMUD how much power is actually being generated by the system. Our system actually has an unused 400 amp breaker that could be used in the future for expansion of additional solar power to be routed through the system. From there, it is a very standard electrical setup in the power room, and that power goes into a building main switchboard, which powers all the things within the structure, such as any energy-efficient lighting, the video display boards you see on the structure itself, as well as the elevators and all of the safety equipment. The last energy meter is another SMUD meter that measures the building's energy use compared to what the solar arrays create. Any excess we create over and above what the building needs, we sell back to SMUD at the going market price. Our parking structure's estimated power usage is 433,000 kilowatt hours per year, and conservatively, we should create 90% of the parking structure's energy needs. Another way to look at these numbers is to imagine that with the averages here in California, this system at CRC could supply power to 34 and one-half houses. Now, the solar industry admits all these estimates are on the extremely conservative side, so it's very possible that the structure pays for itself and may even create a small profit as well.
Alrighty, pretty cool up there with the solar panels and creating energy like that, coming all the way down through the main power room like we saw. All that power's got to go somewhere, and not only does it benefit the school in terms of being green and providing sustainable energy from the sun, but it also helps with some of the newer buildings we have, the technology that we use in conjunction with other things. Let's go inside the Wind Center that we're standing in front of. Now, the Wind Center is one of the new buildings along with the parking structure here on campus, and the Wind Center itself houses most of the construction, architecture, and especially the photography labs and classroom settings. So we'll go inside, we'll talk with Professor Jim West and see just how he feels about some of the changes and see some of the things that are interesting in there. So let's go inside for the tour in there.
So the building was designed around light, which is amazing for photography because with photography, it's all about light. And so we have solar tubes that are in the photography department. We can walk into a room and it's already lit up without turning on any lights at all. So that's just amazing for us. The solar tubes, we're able to vary the amount of light that comes out of the solar tubes, and we've also used that for photography as well. Also, the amount of the solar panels that are on the roof here, for me personally, it just feels amazing to be able to be in a new building that benefits from solar power. A big step has been also the new parking garage. And in the parking garage, we have solar panels on top of the parking garage, and we also have plug-in stations for vehicles, electric vehicles.
All right, pretty cool stuff there with the solar panels and the roof on top of the Wind Center, and especially the solar tubes. Those really turned me on, the light there. Okay, here we are. We're outside the parking structure itself. Let's go inside and find out how it all benefits us, solar panel, here at school and the people that use it.
Well, this happens to be a Nissan Leaf, and it's 100% electric. It goes roughly about 90 miles on one charge. The only reason we probably got an all-electric car was because of the building of the parking structure here at CRC. And without that, I doubt if I would have bought or leased a 100% electric vehicle. I mean, when you think about caring for the environment, I'm not an environmentalist, but I do care about the environment, concerned with conservation. But at the same time, it's got to work economically. I teach ag economics, and it's got to work economically, or it doesn't make sense. And a lot of decisions we make sometimes don't make that kind of sense.
Solar energy generates about 11,000 times Earth's annual energy consumption. So if we could harness even a fraction of that energy, we could reduce our need for burning fossil fuels, and that would be a lot better for the environment. At CRC, we're really excited about the potential to use our new parking structure solar panels as a teaching and learning resource. Those panels are actually generating electricity, which are powering up cars, electric cars on campus. We have a lot of flat-roofed buildings here on campus, which there aren't trees in the way. We could actually generate a lot more solar energy. There's been some discussion of actually generating enough energy to heat our swimming pool using solar panels on top of some of the buildings. So we're hopeful on behalf of faculty and also the Campus Sustainability Committee that we'll have more solar energy generating panels on top of our roofs in the future.
All right, well, thanks for coming along on the tour. Hope we showed you some interesting things here on the Cosumnes River College campus about how our school here, CRC, is trying to provide a little bit more sustainability for not only the school's energy, but also helping the planet as well. The really good part about this is all of the energy that we create here at the parking structure itself goes into a net metering program, which the government has, which has the energy companies buy back the energy we don't use. For instance, if this project here, the structure, creates more energy than it needs, then the government buys that energy back from us at the going market rate. So
that it's kind of a profit for the school as well, although the school uses enough power. We're not going to be giving back that much power, obviously, because we use it. We have more room to put more here, as well as other places around the campus, as you saw. So I think it's a really good thing, and it's a good thing that the school is doing to try and provide for this. I've enjoyed the tour. Hope you have too. Thanks for being with us. I'm Rick Stewart here at Cosumnes River College.